What the Hay Forage webinar series. This first session in the series is going to focus on understanding forage quality and basically cover a lot of the concepts behind what is good quality hay or what makes good quality hay. I wanted to turn my video on just for a minute so I could say hello to everybody, so you could all see me, but I might actually turn it off just to make sure that I can maintain good connection and not lose signal or anything like that. So I'm going to do that now. And also for anybody who is just joining us, if you would like to participate in our interactive session, I've tried to build a few questions and Q&A things into this presentation. So if you want to participate, you can join in one of two ways. Either first following the web instructions, which you see on the left side of your screen, or secondly, following the text instructions, which you see on the bottom right of your screen. And maybe Megan can quick type that into the chat box, so anybody who doesn't get it typed in before I move to the next slide can still participate. Okay, so to test it out, this is the first of our interactive questions. I would just wanted to give it a trial run and make sure people are connecting if they're able to. So you either need to go to the web link or text to the number 37607 and let us know what type of livestock that you work with. And this will just give me a little bit of a feel also for the species that you guys have and the livestock that you're working with, and we can maybe talk more specifically about those as we go through the presentation. So I see that it's working. We have a few answers, a variety of livestock species: horses, goats, chickens, ducks, bees, sheep I see in the chat box. Great, so everything looks like it's working. Thank you all for chiming in. We have a nice variety of livestock species in our participating audience. So when we think about forage quality, what we want to do when we're kind of thinking about it or defining forage quality is recognize first and foremost that quality varies a lot, both among and within forage types. And forage quality is essential, of course, for high rates of gain, production, high performance if you're speaking about horses, and forage quality being the basis of all of our livestock species rations. It will have a huge effect on our animal performance, on their consumption, on your profit margins, other supplemental feeds that may or may not be required. So forage quality is a really important concept to think about when we are considering ration balancing and feeding for our livestock animals. So I'm just kind of curious what you all think of when you think of the term forage quality. What words or what phrases first come to mind if someone were to ask you, what is forage quality? I'll give you guys a second to respond to that one. So we have protein content so far. In the chat, there is a few chiming in: roughage, nutritional value, digestibility, something that's nutritious. Yeah, these are all really good terms and really good things that we think about when we are considering forage quality. So what really does forage quality mean? Well, forage quality is often intertwined with the term forage nutritive value. And technically, or a lot of times these words are used a little bit interchangeably, but if we really want to get down to it, they're actually slightly different in their definitions. So forage nutritive value is the actual concentration of available nutrients, including the energy, the protein, the fiber, the minerals, the vitamins, what is actually in that forage, and what nutrient concentrations those are present at. Forage quality, on the other hand, is a little bit of a broader term, and it includes these nutritive values plus other factors. And we'll look at what a few of those additional forage quality factors might be. Some of those factors might be things like palatability. If a forage is high quality in that it has a high nutrient concentration, but our livestock aren't going to eat it, it's really not going to do us any good. Same thing goes with intake. How much of that forage will they eat? Digestibility. Will they be able to get those nutrients from that forage, or will that forage simply pass through their digestive tract and be excreted out the other end? The nutritive value is that level of nutrients in that forage at an appropriate level, and then also if there are any anti-quality factors or compounds present that could cause problems, whether from a toxicity standpoint or other anti-quality factors like that. So really, when we think of forage quality, we should really be thinking of the extent to which a forage has the potential to produce a desired response. The purpose of that forage is to feed that animal and cause it to grow or produce or perform how we want it. So that's really what it comes down to when you think about forage quality as a big picture. This is to just put that into a little bit of a visual perspective. You see at the top of this figure, we have our animal performance, and below it, we have a whole host of factors that are all contributing to that performance. If we look for nutritive value, we see that down here on the lower left, the actual nutrients that make up that forage. When we think about forage quality, it's the big picture. It's all of those nutrients plus the anti-quality factors, the intake, the feeding value, the digestibility, all of those things. So I just wanted to give you a little bit of a visual perspective on kind of the real difference between those two terms. And we're going to talk about where those differences lie and go into a little bit more detail kind of in both of those categories. So first, we're not really going to go over forage testing today, but I did want to mention that forage testing can be a really important tool because our nutritional value really can only be evaluated with a forage analysis. If we feel or touch or smell or look at a forage, we can tell certain characteristics about it, but we're not going to know the actual nutrient content of that forage. To give you a little bit of an example of that, a few years ago, they did a study where they had 4 types of hay at one of our large forage conferences, and they asked a lot of industry specialists, extension personnel, university faculty to rank those 4 hay samples based on their relative feed value or their overall forage quality. The bars that you see here are the 4 hay samples and their actual feed value. And the numbers that you see above those bars are the percentage of people who thought that was the highest quality forage. So you can see that almost half of the people that they asked thought that hay number 1 was of the highest quality when in fact it was actually of the lowest quality. So that's just to illustrate that looks can be a little bit deceiving, and forage testing can be a really important tool in our toolbox when it comes to forage quality. So when we think about forage nutritive value or the actual nutrients in our forage, a lot of times we submit a sample to a lab and we get a form back that looks something like this. I'm not expecting you to be able to read all of those things on that form, but here is just a list of some of the nutritive values that we can get back from those forage analysis. And we know that this can be quite overwhelming. There's a lot of information provided in that forage nutrient analysis. So we're going to go through not all, but a number of the key or the more important nutritive values associated with a forage test. First and foremost is dry matter. Dry matter is basically the percent of a forage that is not water. So we know that pasture, for example, contains a lot higher concentration of water. So the dry matter percentage is a lot lower. Pasture on average is maybe 10 to 25% dry matter. On the flip side, hay has been cut and dried before it was baled. So a lot of that water has left the forage. So hay contains a lot less water or a much higher percentage of dry matter. Hay is usually in the 80 to 90% dry matter range. And this is important because we want to be able to compare our different forages and our different forage types on an equal basis. And if we're looking at some things with a high percentage of water and some things with a low percentage of water and comparing the nutrients, we're really not doing an equal comparison. So for an example, in the table on the bottom, you see that there is a grass pasture and a grass hay with a few of the nutrient values. Now, don't worry too much about exactly what those nutrient values are, but look at the dry matter percentage, or the DM. For the grass pasture, it's a 20% dry matter product, and the hay is a 90% dry matter product. This is on the as-fed basis, or the wet basis, so not on a 100% dry matter scale. If we convert both of those to 100% dry matter and adjust those nutrients accordingly, we see that those forages are actually identical in their nutrient composition when they're compared on that equal basis. So really the point behind this is that when we're comparing nutrients and looking at forage tests, it's really important to focus on the percent dry matter column and not on the as-fed basis, because we really want to be making an equal comparison across our different forage types. So looking at kind of a plant cell structure, or a forage plant structure of a cell, we can kind of divide this into two general categories. The first is the structural components of that cell, or mostly what is in the cell wall of that plant cell. The structural components are much more fibrous, they're much less digestible, and they're there to provide the strength and support that that plant needs to grow upright and maintain its integrity and not, fall over or flop over. On the inside of that plant cell, or the cell contents, are the more soluble components. So these are more of the easily digestible things that are found within that cell structure. So when we're talking about our different forage quality parameters, I kind of broke this down into what fits into a structural component and what fits into a more soluble component. And first we're going to focus on the structural components, or that cell wall. So think the fibrous, the strength, the support, those kinds of things. The three key components in a plant cell wall are cellulose, hemicellulose, and lignin. You've probably heard of these before, but these are all structural carbohydrates, and they're all responsible for making up the fiber portion of that forage. The first term for fiber is neutral detergent fiber, or NDF, and this includes cellulose, hemicellulose, and lignin. So all three of those structural components are included in the NDF concentration, or the NDF analysis. These are, as I said, the primary cell wall components, and we know that as the NDF concentration of a forage increases, the fiber concentration increases. This is important from a nutritional standpoint, because we also know that as the NDF concentration increases, intake goes down. So those animals can only consume a certain percentage or amount of high fiber before it will slow their intake, because it takes that fiber a long time to work its way through the digestive system, and it causes a lot of gut fill through that digestive tract. So if you're thinking of NDF, remember that it's a measure of fiber, and it is negatively related to intake. The next fiber component is ADF, which is the cellulose and the lignin. So it's a subfraction of our NDF, and it excludes the hemicellulose. Of those three fibrous components, hemicellulose is the most digestible of the three. So ADF, because it excludes that, is a measure of the least digestible portion, or the most indigestible part of that plant. Similar to NDF, ADF is also associated with the fiber content, but because it contains those lower digestibility portions, it's negatively correlated more with digestibility. So when you think of ADF, you can think of the more indigestible fibrous parts of that plant, and that it has that negative relationship. When ADF analysis is higher, the digestibility of that forage will be lower. And then the last one of our structural or fibrous components is lignin. This is really kind of the skeleton of that cell wall, or kind of the mortar in a brick and mortar that's holding everything together. The thing with lignin is it's basically an indigestible fiber. So livestock are really not able to digest lignin. Again, increasing lignin will signify increasing fiber, but really because lignin is indigestible, it also has a negative relationship with digestibility. So those are the three major fiber or structural components. If we move from that cell wall or that more fibrous structure into more of the interior of the cell, the next few things that we're going to cover are stuff that's coming from the cell contents or the inside of that plant cell. The first is non-structural carbohydrates. So these are more of the simple carbohydrate forms, like our starches and our sugars. These things are very readily available as an energy source. They're rapidly and easily digested within the gastrointestinal tract. I will say, depending on the forage lab that you send your sample to, if you don't see a non-structural carbohydrate value on there, the non-structural carbohydrates, oh, that's actually a typo, is the water-soluble carbohydrate plus the starch portion. So sometimes, you know, depending on the way that they analyze their different components in a forage lab, you may see only the water-soluble carbohydrates, ethanol-soluble carbohydrates, and starch on your form, and not the overall non-structural carbohydrates. So if you are in that situation, it would be the water-soluble, or WSC, plus starch to calculate your non-structural carbohydrates. Another thing that is in that interior of that cell is the fat content. Forages overall are not a very high source of fat, but we can see on a forage analysis an estimate of fat content that will be labeled as crude fat. And this is measured in the lab via something that's called ether extraction. So it's an estimation of the fat in that forage. Like our non-structural carbohydrates, fat is also a readily available energy source. And the thing about fat is that it's a high density energy source. So a similar amount of fat will be denser and will contain a higher amount of energy compared to a similar amount of our non-structural carbohydrates. Fat is also rapidly and easily digested within that cell and broken down. Also inside of our plant cell is our crude protein concentration. We know that protein, of course, provides the essential amino acids that we need. One thing to keep in mind with a forage analysis is that protein is not directly measured. It's actually calculated or estimated based on the nitrogen content. So the analysis that they do in the lab measures the total amount of nitrogen in a forage and then calculates the crude protein from that nitrogen amount. So because of the way this analysis works, our crude protein fraction includes the true protein, or the actual protein that's available, as well as some non-protein nitrogen sources. So just keep that in mind. So if we move into kind of more of the measures of digestibility, the first one is dry matter digestibility, or the extent of dry matter digested. This is basically a broad term for the digestibility of a forage source. So here's where we have our next question. How do you think digestibility can be measured? Here you can just answer A, B, C, D, or E. A for feeding trials, B for animal studies, C for laboratory studies, D if it's calculated mathematically, or E if you think it can be calculated via all of the above. We'll give you a couple of minutes. All right, so far we have a few responses for E, all of the above. Looks like everyone is in agreement, and you would be right. So there's a lot of different ways that we can calculate digestibility from our forages as well as from other feedstuffs. So digestibility can be measured in vivo, in situ, or in vitro, or calculated from ADF. So what does that mean? Well, in vivo is within the animal. This would be kind of a traditional digestibility study where you measure everything that goes into the animal and the dry matter concentration of what you're feeding that animal, and then you measure everything that's coming out and the dry matter concentration of what's coming out, and you calculate the difference between those. In situ would be a very similar concept, but basically uses a rumen, cannulated rumen in a cow, and they would put samples in little baggies inside that rumen to be digested for a given amount of time, and then take them out and resample those and again calculate the difference between the before and after. They've also developed ways to do this in the lab, or in an in vitro situation, which would basically be a fiber digester that can be done in the lab and used to measure digestibility that way. And then it can also be calculated. They've done a lot of work looking at calculations for estimating measures or digestibility, and ADF being that kind of most indicative measure of digestibility of our other forage components. Digestibility can be more than just dry matter digestibility. We can also calculate the digestibility of different nutrients. One example would be nutrient fiber digestibility, or excuse me, neutral detergent fiber digestibility, or NDFD. This is basically the same thing as dry matter digestibility, but instead of measuring the dry matter before and after, we're measuring the NDF before and after to calculate the extent of that NDF that was digested. Usually for NDFD, this is reported within a certain time period. So for example, you might see something like NDFD 48, and that just means the amount of NDF that was digested within a 48-hour period. Looking at digestibility, but also kind of switching gears a little bit to more of a measure of energy. One of the most common things that you'll see on a forage analysis is something called total digestible nutrients, or TDN. TDN is a measure of the total energy value in a feed. So it's looking at all of the energy sources, carbohydrates, fat, etc., fiber, and looking at the energy that was available after that forage or feedstuff was digested. So how much of that energy that's in that forage is available to the animal. This is not measured directly, but is calculated based on all those different parameters. Protein, fat, fiber digestibility, all go into the equation to calculate TDN. And they've also developed different calculations based on some of the different forage types. So for example, a legume has a slightly different calculation than a grass would have. Another measure of energy that you may see is digestible energy. This is the energy available for use after fecal losses. And it's kind of just a different way of measuring energy or calculating energy. Digestible energy is more commonly used for things like horse or poultry feed. And basically, it takes the gross energy or the amount of energy available from a feed, looks at how much of that is digested, and then looks at how much energy is put out or was not able to be digested. And it looks at the difference between those. Oh, there's our output. So we have gross energy minus anything that was lost through the fecal losses, gives us our digestible energy concentration. And for a lot of horse rations, digestible energy is still the basis for where we start for looking at energy content of our different forages, and also for our concentrates as well. A lot of cattle rations or swine or sheep take this a step further and look at net energy. And net energy is basically going along that same track, but in addition to accounting for fecal energy loss, it's also accounting for gaseous losses, urinary energy losses, heat energy losses. All of those pathways are ways that energy leaves the body, or we use energy to stay warm or to breathe, etc. So net energy accounts for all of those different things and looks at the amount of energy that's actually available to maintain body weight or support production, whether that be growth or gains or lactation, if we're looking at the dairy. So that net energy, you may see it kind of partitioned out into net energy for maintenance, net energy for growth or gain, and net energy for lactation. But this is basically just a more specific calculation, going a little bit further than the digestible energy calculation does. So those are a whole bunch of different forage quality parameters, and it's hard when you're trying to think about different forage types to think what qualities should I focus on, what's a good way to compare these different forages or these different forage types. Well, really, when we're thinking back to that high quality forage, we want something that's highly digestible, so it has a high TDN or total digestible nutrients. And we also want it to be readily consumed or to have a high intake. So what a lot of scientists have done is compiled all of these different factors with digestibility and intake and things like that, and looked for a single measure that can kind of represent our overall forage quality. And by compiling this all down into a single measure, this allows us to make comparisons across our different forages, our different forage types. There are two measures that have been developed that we're going to talk about for this overall forage quality. For both of these, they're not directly measured, but they're calculated based on all of those other nutrients. So they take into factor the total digestible nutrients, they take into factor the dry matter intake, and they use those in calculations. The first one is relative feed value. So as I mentioned, this is a single measure that kind of looks at our overall forage quality. And it accounts for both of those two parameters, our total digestible nutrients, as well as our dry matter intake. Our digestible dry matter is predicted from the ADF value. Remember, we said that ADF is tied with forage digestibility, and the intake potential is predicted from the NDF value. Remember, NDF was related or inversely related to intake potential. So it uses those two measures and calculates the RFV, or the relative feed value. There's no units for this, but it is a way to compare the potential of two or more forages for overall energy or overall forage quality. I will point out that the relative feed value does not take into account the protein content of the forage. It mostly looks at energy, digestibility, and intake. So over time, RFV was becoming more and more widely used, but it became apparent that really wasn't as good of a measure of overall forage quality because, for example, cattle eating the same RFV types of forage would have different levels of milk production. So they kind of went back and reevaluated this and came up with a new overall forage quality measurement that's called relative forage quality, or RFQ. And this does the same thing. It accounts for both the total digestible nutrients as well as the dry matter intake. But it also takes into account the fiber digestibility portion, or that NDFD parameter. And it also looks a little bit further at the digestibility by focusing on our total digestible nutrients, or TDN, instead of ADF. So it's basically kind of the new and improved relative feed value, if you will. I wanted to put both of these on here because a lot of forage tests will still report relative feed value. So I wanted you to be aware of both of these and the differences between the two of them. So if we think about relative forage quality, just to give this a little bit more of a visual, I borrowed this example from a fellow forage specialist who used to be at the University of Georgia. And on the left-hand pile of this image, or the left-hand side of this image, you can see a 25-pound pile of alfalfa forage. They measured the volume of this pile, height, width, etc., and found the volume to be 12,000 cubic inches. And the TDN of the forage in that pile is 60.2. On the right-hand side of the image, we see a similar pile, again, 25 pounds, but this time it's a Bermuda grass forage. So a grass versus the legume. The pile volume for the Bermuda grass was 24,000 cubic inches, but the TDN was very, very similar between those two forages. So if we think about that, here's my next question for you. Which of those piles would have a greater relative forage quality? Would it be A, the alfalfa pile, B, the Bermuda grass pile, or C, either pile? They're going to be equal. Okay, we have several responses for A, the alfalfa pile. A couple for C, either pile. All right, let's break this down a little bit. So here's our two piles. We see that they have similar total digestible nutrients, so they contain a similar amount of energy between the two piles. The relative forage quality is higher for the alfalfa pile. You can see it's 145 roughly versus 110 for the Bermuda grass. Well, why is this? Even though the energy content is similar, why is the relative forage quality higher? Well, the alfalfa has a greater RFQ because it has a higher intake potential. The livestock are able to consume more of that alfalfa, thus they can consume more total energy over the same amount of time compared to the Bermuda grass forage. And that comes back to that intake and the fiber and the gut fill, and you can see the difference in the overall volume between those two piles. So if we think about that from maybe more of a human nutrition standpoint, we might think of something like a plate of French fries versus a plate of peppers. If we wanted to consume, those two plates might contain equal energy concentrations, but because the plate of French fries is much smaller and that is a really large plate of peppers, we might not necessarily be able to eat all of those peppers and get the energy that we need from that plate versus the plate of French fries. So hopefully that helps make sense a little bit and kind of clarify why it's so important that we account not only for the energy concentration and the digestibility, but also the intake potential and the fiber content kind of behind that between our forage types. So I kind of went through a lot of nutrients, I realize, and I wanted to kind of, for anybody who's just getting started with forage quality and still feels really unsure about it, I wanted to go over, just mention a couple of the really key nutrients that I would start with or that I would focus on first. First is looking at that fiber content. So we know, again, NDF is related to intake, ADF is related to digestibility, and when we're thinking about fiber, we want something that's not too fibrous. Take these percentages, a little bit with a grain of salt, because this will depend a lot on the type of animal that you have, their stage of life, their level of production, their amount of work, etc. So these are just some really, really rough guidelines that I wanted to give you an idea of where we can start thinking about these different concentrations. So an NDF for, say, a grass hay that's less than 50% would likely be a lower fiber source, a lower fiber content in that hay. An NDF that's higher than 60% would likely be a higher fiber content or a high fiber hay. Thinking about energy, there are a few different nutrients that we can look at. We can look at the TDN, the digestible energy, or the net energy. If we think about TDN, roughly anything that has less than, say, 55% would be more of a lower energy source. Anything that has greater than that 65% would be more of a higher energy source. Again, the amount of energy that is needed will vary depending on the animal and their stage of life, which we're going to talk about in a later one of our webinars. But just to give you a rough idea. And then for protein, we of course want to make sure that our forage source contains enough protein. So anything less than maybe 8 to 10% would be considered more of a lower protein source for forage, and anything that's maybe higher than 14% would be considered a higher protein forage source. So those are kind of the key ones that I would start with if you're just getting going and trying to figure out, you know, all of these different nutrients and which ones to focus on. Obviously, there are a lot more and a lot of good, valuable information to be gained from those, but I just wanted to give you kind of a place to start with that. So that being said, we're going to shift gears a little bit and switch kind of from the forage nutritive value, or those nutrient concentrations, into a few of the other factors that can affect forage quality. So we know that forage quality varies greatly based on all these different factors that you can see: stage of maturity, leaf to stem ratio, species differences, etc. So we're going to go through just a few of these to give you an idea of how these different factors influence forage quality and things to consider when we're thinking about our forages and if it's the right fit for our system. So the first is maturity. Maturity is pretty much the greatest determinant of nutritional value from a forage standpoint. When forages are vegetative, they're smaller, they're leafier, they have higher energy concentrations, more protein, more minerals. And then when they grow and they get more mature, those cell walls that we talked about, or that structural component, has to grow to keep that forage standing and upright and maintain the integrity of the plant. So we have a higher stem concentration, those forages are higher in fiber, and a little bit lower in our energy and our protein. So maturity plays a huge difference in forage quality. Just to give you an idea, here's a figure showing the age of grass in weeks along the x-axis, and the two lines represent dry matter digestibility and crude protein concentrations, and you can see that these are both decreasing quite rapidly over time. So again, a higher maturity forage is a lower forage nutritive value. And then that will play a role in the digestibility as well. I'm not going to go through everything on this figure, but basically as you go down the rows, the cutting date for the forage got later and later. So the growth stage got more and more mature. And you can see that intake levels went down and digestibility concentration, or digestibility, also went down. So that increase in maturity resulted in a lower intake and a lower digestibility from that forage source. The next factor is leafiness, or the leaf to stem ratio. And this is because the leaves in general are higher quality than the stems. Leaves have more of those cell contents, the inside of that cell that's more easily digestible. Stems have more of those structural components that are less digestible. And leafiness, or the leaf to stem ratio, is really closely tied with maturity. So we already said that when forages are more immature and more vegetative, like what you would see on the left side of this figure, there's a higher percentages of leaves and a lower percentage of stems. As those forages get more mature, or the days continue, that leaf percentage decreases and that stem percentage increases. And that's what attributes to a lot of the change in the quality occurring in that plant. This is more for the hay making process, but just so you're aware, leaves can also be lost during the hay making, depending on the different management strategies that are used as we go through the hay making process. So that's just something to be aware of as you're thinking about forage quality and leafiness. There are also differences in forage quality based on our different forage species. So here I have some of the major nutrients that we talked about: total digestible nutrients, protein, 2 of our fiber values, calcium, which is one of our minerals, and then RFV, or relative feed value. And I've broken it into 3 categories. The first is cool season grasses, which will be our traditional cool season grasses like orchard grass, Kentucky bluegrass, fescue, etc. Then we have our warm season grasses, which would be things like Bermuda grass, Bahia grass, etc. And then in the last column, we have legumes, which would be things like our clover or alfalfa. And we can see that in general, although there's a range within each of these species, there are kind of some trends we can pull out. So for example, legumes tend to be a little bit higher in energy. They tend to be a little bit higher on that TDN scale. They also tend to be a little bit higher in crude protein, versus our warm season grasses tend to be a little bit lower in crude protein compared to our cool season grasses. For our fiber values, our legumes tend to be lower in total fiber concentration, and our warm season grasses tend to be higher in the total fiber concentration. Legumes tend to be a little bit higher in their mineral concentration, especially for things like calcium. And they also tend to be a little bit higher in their overall RFV or relative feed value. Warm season grasses are typically slightly lower compared to our cool season grasses. But again, this also takes into consideration things like maturity, which will have a huge impact on this as well. So to kind of portray that, here is a similar setup, but a little bit more of a bar graph. This is looking at relative forage quality. Each of the forage types are along the left side. So you can see it starts with small grains and annual forages at the top, and then kind of works its way down through different types of forages. And I wanted to show you this because the dark bar that's in the middle of each of these multicolored bars is showing the average relative forage quality. And these were all samples that were submitted to the University of Georgia Forage Testing Lab over, say, like an 8-year period. But on average, we have, here's our cool season perennials, like our fescue and our orchard grass, versus our warm season perennials, like our Bahia grass and our Bermuda grass. And you can see that average is just slightly higher for those cool season forages. And then here is an average for our legumes, like alfalfa and other legume crops. And you can see those tend to be a little bit higher on that relative forage quality scale. But again, if you look at the width of some of these bars, you'll see that there is a huge range even within, say, for example, the alfalfa category. And this is portraying to a lot of those other factors like maturity, leafiness, management, etc. So keep that in mind when we're thinking about these trends with forage quality. One other thing that affects forage quality is the fertility of the soil. We know that the soil pH can affect the availability of nutrients within that soil. And we also know that fertilization of our grasses with adequate nitrogen will not only increase the yield, but usually has an impact on the protein levels as well. This again would be something less so for a hay purchaser to be aware of and more so for anybody who's making hay, but it might be something to think about. You know, if you know your hay supplier has good soil fertility and follows these good management practices, they'll likely have a higher quality product. And then we have our time of day or time of year. We know that our forage quality parameters fluctuate over time. There's natural fluctuations in some of these different parameters. One example of this is our non-structured carbohydrate levels. These tend to accumulate in the plant during the day. They're building up that non-structured carbohydrate, building up energy, and then those carbohydrates are used overnight as the plant uses them for growth, etc. So there's this kind of natural curve that we see with these levels changing at different times of the day, and this is also true for different times of the year as well. And then finally, we have different harvest and storage techniques. So we know that the conditions that are in the field when the hay is being dried, we know that there are different management practices when it comes to baling that hay. And then we're going to talk about this in one of our future webinars, but we know that there's a lot of impacts on forage quality from withering or other things that can happen during the storage process. So all of these things are things that will also influence forage quality and are something to be aware of as we're thinking about forage quality. So to wrap all of that together, basically we know that forage testing allows for an accurate quality assessment If you're not getting your forages tested, I highly recommend that you do so, so that you know what the nutrient content that you're feeding to your livestock is. When it comes to understanding forage quality and those different parameters, first we should focus on some of the key values like the fiber concentration, the total energy or total digestible nutrients, and the crude protein concentrations. And we can use values like our relative forage quality to make kind of comparisons across species and different types of forage, and use that for kind of some general comparisons. Lastly, we should be aware of some of these different influences like forage maturity, leafiness, forage species, etc. All of those different factors that we just talked about, because they will all play a role in forage quality as well. With that, I did have my contact information on this last slide, so feel free to reach out if you have questions or concerns. And I think we have some time to answer some questions now, if there are any.